and 47, Strobogrammatic number 2. So first of all, we need to understand what's gonna be a Strobogrammatic number. So this number gonna be a number that looks like the same when rotated 180 degrees. Basically, it looked at upside down. So according to this information, we should know that if this n equals to 2, it means the length of the string gonna be 2, and the result gonna be like 11, 69, 88, and 96. So if n equal to 1, there's gonna be only 0, 1, and 8. Yeah, because for other numbers, if we turn it 180 degrees, definitely it not looks the same. So for example, if this number, maybe, yeah, it is 7. So what happens if we turn it 180 degrees? Definitely it is not the same. Yeah. So yeah, maybe something like this. Yeah, but definitely, it's not the same. Yeah. Yeah, maybe not like that. If we turn it 180 degrees, yeah, you can try. So this is a 7, and for this line, you want to turn 180 degrees. So this line gonna be the same, but for this line, you want to turn 180 degrees. Maybe it is here. Yeah, it means the numbers are not the same. Yeah, but for all other numbers, for 6, for a single number, it's not the same. But if it is a 69, if we turn it 180 degrees, it's gonna still be the 69. Yeah. So that is why if this n equal to 2, it's gonna be 4 numbers. If n equal to 1, it's gonna be 1 number. So according to this kind of information, what we can do to solve this problem is that basically we're gonna use backtracking because this n is gonna be maximum 14. Yeah. So this is what we are giving. If n equal to 1, we are giving this array. If n equal to 2, we are giving this array. So this means if n equal to 3, we can use the previous information. Yeah. But how can we make it? So the idea is that if n equal to 3, we're gonna use this n equal to 1 because we are giving 0, 1, and 8. And what we can do is we just want to put n equal to 2 at both sides of n equal to 1. So this means this is 0, we're gonna put 11 at both sides, and we're gonna put 6, 9 at both sides. As you can see, it will work. And we put 8, 8 at both sides. As you can see, it works. Or at this position, you can also put like 6. This is 0, this is 6, 9, and this is 0, this is 8, 8, and this is 0, and this is 9, 6. Yeah. So according to this way, definitely you can prepare all those numbers. So this means this problem is solvable by using the backtracking. So this means if n equal to 3, we're gonna use the information from n equal to 2, and we're gonna check all the possible cases. Yeah, n equal to 3, we're gonna use the base case n equal to 1, and then we're gonna use the case of n equal to 2. Basically, this is 3 times 4. There will be 12 different cases for n equal to 3. Yeah. Now let's just write the backtracking to solve the problem. So we're gonna prepare a spacer pairs. Basically, this is for n equal to 2. We're gonna have those 4 spacer pairs. But we need to be careful with the spacer case, which is gonna be 0, 0. Yeah. So for the 0, 0, if n equal to 2, we cannot put 0, 0 at both sides. Definitely, we cannot put 0, 0 inside the pairs array because if n equal to 2, it's not inside. So we have to do a special check. Yeah. Now let's just write the backtracking function, and I'm gonna prepare a number x. So this x gonna be this number n. We're gonna put the because finally we're gonna return this backtracking, or maybe we want to write the DFS because it's definitely we're gonna directly return this DFS. Actually, it is a backtracking. So we're gonna put the number n inside, and there are 2 cases we need to check. If x equal to 0. This is not given, but we need this kind of a special case because n equal to 1 to 14, but we still need this x equal to 0. This is our base case. So the base case is gonna be array and empty string. So this is used for the further calculation. So another case is x equal to 1. Yeah, so we're gonna return this case. It's gonna be 0, 1, and 8. Now we're gonna check what happens if x more than or equal to 2. Yeah, so this is the base case 0 and 1. Now we have another case, so it's gonna be x more than or equal to 2. So we need to check all the numbers inside this x more than and equal to 2. So it's going to be a DFS with x minus 2. So for example, if x equal to 2, what's going to happen? If this n equal to 2, this x equal to 2, and this going to be DFS 0, so it's going to be an empty array, and inside it's going to be an empty string. Yeah, so if it is empty string, so we're going to put all those strings at both sides of this empty string, and we produce the result for n equal to 2. Yeah, so the case is going to be we're going to prepare a result array from here, and we want to check all the pairs. So for AB inside our pairs, so this is what we prepared, and our result is gonna append A plus the num plus B. So currently this is A num and B, all of them are strings, so that is why we can use plus directly. Yeah. Now we get all the cases. Let me return this result to check what's gonna happen for us currently. As you can see, it works. It passed for testing case 1 and 2, but definitely it didn't work for all testing cases because we didn't consider what happens for this 0 and 0 case. I mean, for n equal to 2, we cannot put 0, 0 inside. But what about n equal to 3 and 4? Definitely we can put it inside. So we only need to do a spatial check from here. So from here, we just put all those numbers at both sides, like 11, 69, 88, and 96. But at here, we have to do a spatial check. This means for our x, it is not equal to n. Definitely, yeah, if it is equal to n, we cannot put 0, 0 inside. But if it is not equal to n, so for example, this n gonna be 3, and currently this x is 2, or currently this x is 1. Yeah, currently this x is 1 because n equal to 2. Currently this x is 1. Definitely we can put 0, 0 inside. Yeah, so it's gonna be result append 0 plus the current num and plus a 0. Yeah. So this num basically it is a string. Yeah, or we can use for string, and we're gonna plus this is string. I think it's the same. Now let me just run it to have a check. Now as you can see, it works. Yeah. So this is gonna be the basic idea. As you can see, it works and it's pretty fast. Basically, this is just a backtracking. We just need to find all the different cases for this kind of a backtracking problem. Yeah, I think that's all about it. Maybe we're gonna analyze a little bit about the time complexity. Normally the backtracking is difficult to analyze, but if this n equal to 14, definitely this is gonna be a smaller number. So currently x equal to 1, it's gonna be something like 3. If n equal to 2, it's gonna be 4. So what happens if n equal to 3? It's gonna be something like 12. Yeah. And if n equal to so this is 3 and 4. 4 times 3 is gonna be 12. So if n equal to 4, what's gonna happen? Yeah. So if n equal to 4, it's gonna be this is inside the pairs, and basically we need to check how many there are. So it's gonna be yeah, something like times 4 or times 3. It depended. I think the final time complexity is like 2 to the power of 20 or more. Definitely we can pass at least for such kind of problem. Yeah, I think that's all about it. Thank you for watching. See you next time.